Hello pre-calculus students, and welcome to our next video here in our series on probability. And in this video we're going to talk about binomial probability. And the word binomial here suggests two. Okay? In other words, this occurs when a sample space, when this means that events in the sample space, this is somewhat of a layman's definition, but it should get the job done, is divided into two distinct groups, distinct and disjoint groups. Okay. For example, this is a non-binomial probability. Would be rolling a cube, and this is, so then the sample space would be, you can get a 1, a 2, a 3, a 4, a 5, or a 6. The binomial version of this, would be if this was our sample space. Let's say we get a 2 or a non-2. So in other words, I take this event, I take the 2 and I make it its own event, and then I make everything else fall into this non-2 category. Okay. So that's the definition of binomial probability. And let's take an example here. Let's take another example. Let's say we roll a cube, let's say 7 times. What is the probability of getting exactly, and the keyword here is exactly, 3 2s? Well, let's just list out some ways that we could get 3 2s. We could get a 2, a 2, a 2, a non-2, a non-2. So I'm going to abbreviate this NT, a non-2, a non-2, a non-2, 1, 2, 3, 4. Okay, so there's 3 2s here, and then 1, 2, 3, 4 non-2s. But I could also get a 2, a 2, a non-2, a 2, non-2, not a 2, not a 2, 1, 2, 3, 4, 5, 6, 7. And there's so many ways that I can do this. Let's see again. So let's say I can get a 2, let me separate these a little bit. Non-2, 2, 2, whoops. Non-2, non-2, non-2. So these, I can list as 1, 2, 3, 4, 5, 6, 7 rolls. Okay, each one of these represents each of these 7 rolls. Okay, and how do I go about listing all of these? Well, you have to think about this a different way. It's like we have 7 slots. 1, 2, 3, 4, 5, 6, 7 different slots. Okay. And I am selecting 3 slots to be 2 and 4 slots to be non-2s. Okay. And the order doesn't matter, because whether I get a 2, 2, 2 and then a bunch of non-2s, or a 2, a bunch of non-2s and then a couple more 2s, it's the same thing. So there are 7, choose 3, or 7, choose 4 different ways to do this. And my probabilities here is going to be 1/6 squared. No, I'm sorry, 1/6 to the third because I want 3 2's, and then 5 6 to the 4th because I want 4 non-2's, and the probability of getting a non-2 is 5 to the 6. So let's think about that again. In other words, the probabilities of each of this getting a 2 is 1 out of 6, 1 out of 6, 5 out of 6. This is 1 out of 6. A non-2 is a 5 out of 6, 5 out of 6, 5 out of 6. Okay. In this first example, a 2, well, that's 1 out of 6, 1 out of 6, 1 out of 6, 5 out of 6, 5 out of 6, 5 out of 6, 5 out of 6. And excuse my sloppiness here, but these are different results. Okay. Let's take a look at this. To get a 2, I need 1 out of 6, 1 out of 6, 1. Whoops, this is 5. This right here is 5. A 2 is 1 out of 6. This one's 5. This one's 5 out of 6. This is also 5 out of 6. This is also 5 out of 6. And if we count these, how many 1/6 do we have? It's 1, 2, 3. Okay. Because we want 3 2's. How many 5/6 do we have? Well, there's 1, 2, 3, 4. Because there's 4 non-2's. And in all of these possibilities, it's the same thing. 1, 2, 3, 4. Oops, I think I messed up in this example. There should have been another 2 here. That should have been a 2. Okay. So this is 1 out of 6. Sorry about that. This should have been a 2. So there's 1, 2, 3, 4 non-2's, and then 1, 2, 3 2's. Now, I've said the word 2's and non-2's and all that stuff so many times, so it may have lost all meaning. But just go back and think about this a little bit. There's 2 events. In other words, when I get a 2, that's like saying yes. A non-2, that's like saying no. Did I get a 2? Yes or no? You can look at these as yeses, and the non-2's as no's. And when I want 3 yeses, there has to be 4 no's. Okay? The probability of a yes is 1/6. The probability of a no is 5 6. I want 3 of the yeses, 4 of the no's. And it doesn't matter what order the yeses or the no's happens in. So there's 7, choose 3 different ways for me to organize that. All right, now that was quite a difficult problem here. And this is probably one of the more difficult concepts that you'll have to work with. Okay? But hopefully this gives you a better idea of how to approach these types of problems. I've listed here this as example 7, but I really want you to think about this, and I really want you to try this on your own. Okay, so really try this on your own and see what answers you get for these, and then we will talk about them in class or ask your teacher for help with these if you should have a hard time. Thank you for watching. This has been a long lesson. Hopefully you're able to keep up and watch all of it. Keep working at this. These concepts require a lot of practice, a lot of patience, and a lot of deep thinking. But if you keep working at it, I'm confident that you will find success and improvement. Have a wonderful day.